All right, so we're looking at 4.4 today. And yep, concavity. Okay, I didn't want to go down too far before I read off what we were looking at. We were looking at concavity and curve sketching. So concave up is when it create that U-type shape. Concave down is when it's upside down. So the definition is what we're looking at. Write it down now. The graph of a differentiable function y equal to f of x is concave up on an open interval, I if f prime is increasing on I. All right, concave down, open interval, if open interval I, if f prime is decreasing on I. Of course, if I scroll up too quickly, let me know. All right, second derivative test for concavity. Let y equal to f of x be twice differentiable on an interval I if f double prime is greater than 0, in other words, positive, and that's the second derivative of f, second derivative of your function. If that is positive on an interval, then the graph of f over I is concave up. If the second derivative of your function is negative, in other words, less than 0, on the interval, the graph of f over I is concave down. All right. Um, I'll say concavity. All right, so points of inflection. This is where the concavity changes. So it goes from either concave up to concave down or vice versa. And so at a point of inflection, when you C, in other words, when you plug C into f of C, either your derivative, your second derivative of f of C is equal to 0 or it's undefined. In other words, fails to exist. Some spot.
Can you back up a little bit?
Right here.
And a little more?
Up, go back up.
Yes, please.
Mm-hmm.
Okay, good, thank you.
All right. All right. Are we still here? We need to. Oh, we're good to go.
I'm still copying that part.
Okay, not a problem.
Okay, I'm getting.
All right, that's cool. That's cool. Let's go to the first example. All right, determine the concavity and find the inflection points of the function x cubed minus 3x squared plus 2. Okay, so let's. All right, so we're going to find the first and second derivatives of our function. All right, so derivative of x cubed, you bring down to 3 and subtract 1 from your exponent. So that's why we have 3x squared. Then we have minus 3x squared. You leave your 3, bring down that 2 for your exponent, subtract 1 from it. And then, of course, the derivative of any constant is 0. So that's why we don't have that here. And that is 3x squared minus 6x. Now, derivative, the second derivative of f, we'll do the same thing for this. And bring down your 2, subtract 1. And then that'll be 6 for the derivative of 6x. So that's going to be 6x minus 6. All right. Questions on the first and second derivative?
Yeah. No questions.
I barely can understand it. You're breaking up.
I said I don't have any questions.
Oh, okay, cool, cool. All right. So now we go back to what they're asking us. They're asking us to find or determine the concavity and then find the inflection point. So if we go back to what influences that, the inflection point is going to be where f double prime or the second derivative of your function is equal to 0. So let's go ahead and find that inflection point. We can set, I guess I can go and plug in and see if we want to keep using the notation. Set it equal to 0. Add 6 to both sides. And y'all approve of this part, so then divide by 6. So we have an inflection point at C equal to 1. So that point when I go back to my f, my full function, my initial function, plug 1 into the equation. Plus 2. All right, so that's 1 minus 3 times 1 plus 2. 1 minus 3 plus 2. And that is 0. So we have an inflection point at 1, 0. All right. That's where the concavity changes. All right. Any problems with that before we go to the next part?
I'm all good over here.
All right. So now we know that's where it changes. When we look at that interval, talking about 1, we're looking at our x value. So we're going from infinity to 1, negative infinity to 1, and then 1 to positive infinity. So if we set up our chart, all right, so we need something that's less than negative 1. So anything will work for that. I mean, less than positive 1. That will work in that interval. Anything will do that. So 0. And then anything greater than positive 1, 2. So any value can work in those intervals. So anything greater than 1, we can use positive 100, positive 1 million. Just remember, whatever you choose, you're going to have to graph it. This graph is going to behave the same way in that interval for all values in that interval. Same thing with less than positive 1. You can use negative 50 if you want. As long as it's something that's less than 1 that fits into our interval. And we're going to use it to test the sign. Remember, all we want to know is it going to be positive or negative in this interval? And that will be whether it's concave up or concave down. But remember, what we're testing is, let's go back up, concavity. What we're testing is that the second derivative of f is less than or greater than 0. So we go back to our function of 6x minus 6 and plug it in. So that's going to be negative 6. So like I said, the main thing that we're looking at is the fact that it's negative. And then plugging in positive 2. That's going to be 12 minus 6, which is positive 6. And this is going to be positive. So anything I plug in that right interval is going to give me a positive result. Anything I plug in on that left inner will give me a negative result. So that means this is going to be concave up, and this is going to concave down. So if you just had to write it up, concave up is going from 1 to positive infinity, and then concave down is from negative infinity to positive 1. All right. Questions on that? Get to my page. All right, let's do another example. All right, you got a chance to write that down. A particle is moving along a horizontal coordinate line, positive to the right with position function. S of t is equal to 2t cubed minus 14t squared plus 22t minus 5, where t is greater than or equal to 0. Where t is represented time. Find the velocity and acceleration. Describe the motion of the particle.
Yeah, I got it.
All right. So let's look at moving forward. So the velocity, let me do it like this. All right, so the first derivative of s is the velocity. Second derivative of s is the acceleration. So let's go ahead and find both of those. As a matter of fact, I'll write s or t right here, just so I don't have to keep scrolling up. I need. All right, so position formula was what they gave us initially. That's s of t, and velocity is going to be equal to the derivative of s of t, and we got 6t squared minus 28t plus 22, and then the acceleration is the second derivative of s, first derivative of v, and that'll be 12t minus 28. All right. So let's look at setting up our intervals. First thing we're going to do is explore our velocity. And it will let us know, going back here to our initial setup, positive is to the right. So just re-emphasizing, let me see if I can say it. I read. All right, so just reiterating what I just mentioned in the notes. Um, Looking at the velocity first, when the function s of t is increasing, the particle is moving to the right. When s of t is decreasing, the particle is moving to the left. So your first derivative test, we talked about that, I believe it was in the last section. Determining intervals of increasing and decreasing, we can use that or do that by using this first derivative. So what we need to do is figure out when is our first derivative equal to 0. So we can set up our intervals like we did last time. So another color. 16. Marking factor out. 2 yeah. All right, so yeah, because I factored out 2, so t minus 1, 3t minus 2 minus 1, 3t minus 11. Okay, yep. All right, so set each piece equal to 0. We can get our zeros, critical points. Oh, just lost somebody. There she go. Test values and behavior. All right, so yep, I don't know if you remember from last class, not the last subject, where we did actually this stuff before. So not talking about last calculus class, what was pre-calculus? And we actually had to set up this same type of table in these intervals. So that was really setting us up for the stuff in calculus. So test value, use 0. I'll use 2 here and 5. And S of t was 2 times t minus 1. All right, plugging in 0. This is not S of t, this is V of t. Sorry about that. Plugging in 0. Remember, I just need to know if the result's gonna be negative or positive. So that's a negative times a negative, so my result will be positive. Plugging in 2. That's going to be a negative 3 times 2. Make sure I'm putting in the right stuff. 1 is greater than 2, 0. 3 divided by 3, that's going to be 9. And that's 2 positive, I mean. Let me see, did I have a cubic equation? Yes, I did. Okay, I'm good. And then plugging in positive 5. So that's going to be negative 15. That's going to be positive. So a negative result. Okay. Make sure I have my values right. 0 to, oh, I just missed one more thing. Hold on. 0 to 1, 1 to 3. And then go to infinity. Oh, I missed them right here. We can't go to infinity. Because remember T, our initial setup. What did I lose? Okay, I must be way up here. Okay, yeah, our initial setup. We can't be less than 0. So that's the first thing. So let's go back and put a 0 here. So that should be good. Now, all right. And then here, 6 negative. Should be okay. I don't know why I feel like that should be a negative. Got positive here, positive here. That's 15 minus 11, so that's positive. 5 minus 11, that's negative. I should, now let me look at the example, got increasing. Yeah, it should be increasing, decreasing, increasing. Okay, so what did I write wrong? There you go. Why y'all let me put that round sign right there? So it should be a plus sign.
Oops, sorry.
And if that's the case, I put a plus sign right here. That means that should be negative 11 over 3. All right, so that's negative 11 over 3. It can't be. Hold on. No, it shouldn't be. No, that should be positive. Right. That's negative. No, that's right. Negative 11 over 3, and it should be positive. And then, because I got 2, I got my positive sign right here, negative, negative. That should be 11 over 3. 11 over 3, negative, negative. Yeah, that should be right. So why am I got 0? That gives me a negative sign, so that is right. Plug in 2 minus 11. 3 times 2 give me a negative 11. Something's not right. What am I missing? What am I missing? Because it's supposed to be increasing, decreasing, increasing. I have my intervals right, 0 to 1, 1 to 11 over 3, and 11 over 3 to positive infinity. So that's right. So if I go put it in here, behavior of V. T minus 1, 3t minus 11. T minus 1, 3t minus 11. T minus 1, 3t minus 11. So t minus 1, when I plug in 0, I get a negative value. 3 minus times 0 is not 11. Plug in 2, that's negative 11. 3 times 2, that's negative 5. And then 15 is going to be positive. It's not working out right. What is wrong? This is supposed to be negative. Should be a negative times a positive. And then down here, I should get positive times positive. There's something going on right here that I'm not seeing. Something I'm not doing right. Oh, that's what it is. Once again, y'all let me put 11s right here. I knew it was something. That is hilarious. All right, so I'm good now. It's supposed to be a one right here, y'all. I was like, wow, it was some. I knew it was something that wasn't.
Yeah, that's what I thought.
All right, so now we're on track now. I just knew. I'm mad at myself. Okay, so now we're good. Now we're good. So that's going to be negative, and that's going to be positive. We are good now. So anybody who's watching this video for the first time gonna have to sit through me trying to figure out. At least I know how to troubleshoot myself. All right. So I'll let y'all copy that before going any further. Oh, while we're doing that, so that means well, I'll write it down here. It's increasing. Intervals are increasing from 0 to 1 and 11 thirds to infinity. Intervals are decreasing, or interval is 1 to 11/3. So that means the particle is moving right here, and in here, particle is moving left. All right, any questions? All right, so it's
No
moving right.
questions.
All right, sounds good, sounds good. So it's moving right on those intervals, moving left on this interval. Then it says it has a momentary, what's a point of rest? Let's see a good word for it. It is momentarily, they say it like that. They say it better than I do. It is momentarily stationary. That's a backrest. At t equal to 1 and t equal to 11/3. All right. And then testing our concavity. I think started out calling this acceleration. Yeah. All right. That one is 12t minus 28. That's 4. 3t minus 7. We have to factor it. Set that equal to 0. All right, so we can do the same thing here. We saw that setting our acceleration equal to 0. We saw we got the one value of t equal to 7 over 3, and that is an inflection point. So getting our concavity straight. So we set that same chart up. I decided to use 0 and 5, something less than 7 over 3, something greater than 7 over 3. Plug that in. That's going to be negative. It's going to be positive. This concaves up, down. This concaves up. All right. Yeah, starts moving. All right. Any questions on that? And as far as all that describing, that's good enough. I don't think they're going to ask you to do any more descriptions outside of that. Particle starts out moving to the right while slowing down. Then it reverses, begins to move to the left. Oh, I guess I can write that just so you can get some words to what all this means. So, full description of what's going on. All right, first sentence, the particle starts moving to the right while slowing down, and the should be and then reverses. Yep, and then reverses and begin moving to the left at t equal to 1 under the influence of the leftward acceleration over the time interval 0 to 7 over 3. So this is how you put all of that together when you start talking about increasing and decreasing and then concave up, concave down, and all that good stuff like that. So just like with a roller coaster, it's going up, it has to slow down, and then when it goes down, it accelerates. So all that type of stuff. So then we got one more sentence that goes along with this. So the acceleration and changes direction. Leftward, not forward, leftward. All right, so I think that was it. So the acceleration then changes direction at t equal to 7 over 3, but the particle continues moving leftward while slowing down under the rightward acceleration. At t equal to 11 over 3, the particle reverses direction again, moving to the right in the same direction as the acceleration. So it is speeding up. All right. So if you were to put those numbers together, our test for increasing and decreasing, concave up, concave down, that's what those things mean word-wise when it comes to the description of what the particle is doing and how the particle is moving. All right, I want to write one last thing down and then I'll let you guys go. May do a few more examples of this next class. I need to check out what the next section is. Next section may incorporate all this anyway. So the main thing we wanted to get out of this section though was the second derivative test of for concavity. All right. right, can I scroll up? Make sure we're okay. All right, so second derivative test for local extrema. Suppose f double prime or second derivative of f is continuous on an open interval that contains x equal to c. So f prime of c is equal to 0. If f prime of c is equal to 0 and f double prime is less than 0, so in other words, it's negative, then f has a local max at x equal to c. If f prime of c is equal to 0 and f double prime is greater than 0, then f has a local minimum at x equals c. Yeah. If f prime of c is equal to 0 and f double prime is also equal to 0, then f, oh, the test, not f, and the test fails. All right, so going back, if f prime of c is equal to 0 and f double prime of c is less than 0, then f has a local max at x equal to c. If f prime of c is equal to 0, f double prime of c is greater than 0, then f has a local minimum at x equal to c. And then final scenario, if f prime of c is equal to 0 and f double prime of c is equal to 0, the test fails. The function f may have a local max, a local min, or neither. All right. Questions on anything before we close out? Okay. I haven't posted this homework yet. I think I need to post 4, 3, 2. So I got a couple sections in chapter 4 I need to post for you guys. I know you guys can't wait to get into your homework. So I'll make sure I get that in there shortly. But try the stuff out. See if you get stuck. Of course, if you have any questions on anything, feel free to shoot me an email, or you can always wait till next class as well. The floor is always open for you to ask questions. You got 2 tests out there. Make sure you get them knocked out, and also don't forget to shoot me a copy of your scratch work once you submit that test. Outside of that, you guys have a great evening. Hope you all are doing well and staying safe. And I will see you on Wednesday.
Bye.
All right, take care.